All right, this is AB Calculus section 6.2, day number 2. We are going to find area by integrating, in this case, with respect to y. Sometimes we'll find that area between curves isn't so easily integrated from left to right with respect to x. So let's take a look at this space here enclosed by these two curves. So let's first take a look at this function right here. This is a function. Now in red over here, this is not a function. And for good reason, we choose not to integrate with respect to x due to that relation right there. So let's go ahead and take a look at these two curves. So first we'll start with the linear function 4x minus y equals 16. So what I'm going to do is I'm going to do two things here. First, I'm going to find some intercepts. So I'm going to plug a 0 in for x. And when I plug a 0 in for x, I get 0 minus y equals 16. So what I end up getting is that y equals negative 16. Okay, so this isn't going to be perfect, but let's go like this. So this will be the point 0, negative 16. Okay, now let's look at the x-intercept, which would be when y is equal to 0. Okay, so when y is equal to 0, plug that in, 4x equals 16. I get this x-intercept of 4, 0. Okay, so I can imagine. Right, and I don't really know why I dotted that. Maybe just to keep some perspective about what's about to come through here. I have no idea, honestly. I could have made that solid, doesn't matter. Okay, so let's look at the relation y squared minus x is equal to 4. Now, this is a relation because you'll see that there are two outputs for many of the inputs. All right, so for example, let's plug in x equals 0. So if I plug in x equals 0, I happen to get out two values. I'm going to get plus or minus 2. So I'm going to get a plus 2. So this would be the point 0, 2, and a minus 2. This would be the point 0, negative 2. Okay, let's find another value. How about because of the symmetry that we have here? All right, let's find when y equals 0. Okay, and that'll actually find us the vertex or the point furthest to the left, the least x value. Okay, so if I plug in a 0 for y, I will get the point, looks like negative 1, 0. Okay, so this is a really interesting curve. That's negative 1 and 0. Okay, this curve is going to take on the shape of a parabola, except it's not a parabola. Okay, so I want you to see something else here. I'm going to take this and I am going to, let's see, I'm going to solve for y. Okay, so I'm going to add 4x. So that'll be y squared is equal to 4x plus 4. And then I'm going to take a square root. Let's work this out. This will be plus or minus the square root of, let's go like this, 4x plus 1. Now look, I get a positive, which is this upper half. And I get a negative, which is this lower half. Okay, so it's maybe some unnecessary details. Doesn't matter. Okay, so as you look at this, all right, this would be kind of interesting to try to integrate with respect to x, right? Like I could I could integrate with respect to x this region right here. I can imagine that, and I'd go from x equals -1 to x equals 4 of the blue portion, and then I'd have to go from x equals 4 to whatever this point of intersection is of the blue function minus the linear function, and then I could go from -1 to this point of intersection. So I'd have to actually find 4 integrals. Right? You can imagine it, right? Like here's space 1, here's space 2, right? Here's space 3, here's space 4. It gets pretty cumbersome. So let's work our way back and see why it is that it'd just be easier to integrate with respect to y. So instead of integrating with respect to x and integrating from left to right, I'm actually going to integrate with respect to y and integrate from bottom to top. So if you imagine integrating with respect to y this way, this dotted line here would be our upper function, and this curve would be our lower function. Now when we integrate with respect to y, we want y to be our independent variable. So I'm going to take this, and I'm going to solve for x. So I'm going to take y squared minus 4x is equal to 4, and I'm going to solve for x. So that would be -4x is equal to 4 minus y squared, and therefore x is equal to y squared minus 4 over 4. Okay, so this is x in terms of y for the red relation. Let's rewrite that. Okay, and then on the other side, for the black, I'm just going to solve for x here. So I would have 4x equals y plus 16, and therefore x equals y plus 16 over 4. Okay, now why did I do that? I did that so I could find these limits here. Okay, I want to find the 2 points where these relations are equal. So I'm going to set them equal, right? I'm going to take, since I have both isolating x, I'm going to set them equal. So let's do that. So let's take y squared minus 4 over 4, set it equal to y plus 16 over 4. And what this is going to do is it's going to find our limits, right, our y values for which these are equal. Okay, so clearly I can drop both of those 4s. Oops, I forgot a squared there. So let's go y squared minus y minus 20 is equal to 0. This is interesting. It's nice and factorable. So this will be y minus 5 and a y plus 4. Therefore, these two relations are equal when y equals -4 and when y equals 5. Okay, so I'm not quite sure what the x values are here, and to be honest, I don't care. All right, so I'm going to integrate these values, or these two relations, from -4 to 5. Okay, now you might be wondering, well, how do you know which one's the lower limit? Well, clearly one of them is negative, one's positive, but also the fact that, like, normally when we integrate with respect to x, we integrate from left to right, and our upper function is always whichever one has a larger y value. So in this case, since we're integrating from bottom to top, we're going to take the function that assumes larger x values. So here are the function with the larger x values. Here is the relation with the smaller x values. So I'm going to integrate from -4 up to 5 of the upper function with respect to y minus the lower function with respect to y. Now this is a function in terms of y, it is a relation in terms of x. And I'm going to integrate that with respect to y. Okay, so let's go ahead and do a little algebra here. All right, so from -4 to 5, this is going to be y squared plus y plus 20, and I'm going to pull 1/4 out in front, dy. Okay, so let's look at the algebra there. Okay, I just brought the 1/4 out in front. If I take this expression minus y squared, oops, I almost missed it. It should be a negative y squared minus a -4, that becomes a positive 4, which added to 16 makes it 20. Okay, I think we're good to go there. Let's continue. Okay, so again, just in case you have kind of lost track of what we're actually trying to accomplish here, we're trying to find the area of this space. Okay, so let's do this. This will be 1/4. Antiderivative will be -y cubed over 3 plus y squared over 2 plus 20y, evaluated from -4 up to 5. Looks like we got some work to do here. Okay, so let's build this. This will equal, and really honestly at this point, I mean, this is just kind of abusive algebra that we're asking you to execute on, but I would just as soon use the calculator, and I already have, just to check to make sure, you know, my answer is accurate, but let's go ahead and do it anyways. This would be -125 over 3 plus 25 over 2 plus, I'm actually going to write this as 100 over 2, right? That's, actually, I'm sorry, that should be 200 over 2. And intentionally so that I can combine some like terms here. Okay, if I sub in a 4, 4 cubed is 64, so that'd be 64/3. And that would be 16 over 2. And that would be 160, oops, -160 over 2. Okay, so if I combine some terms that have common denominators, right, I get 1/4 of -125 minus 64 is -189/3. And combining the other terms, 25 halves, 200 halves, 16 halves, and 160 halves, I get positive 369 halves. Okay, so let's try to put this all together. This would be -189/12 plus 369/8. And to get a common denominator, I'm just going to get this in terms of 24ths. Okay, so -189 times 2 is -378, and 369 times 3 is 1107. You might be wondering, why am I still watching? I don't blame you. And it looks like I get 729 over 24, which comes out to be what I was hoping. So that yellow space ends up being 30.375. Now, again, you might argue all day long, like, hey, if you had to use the calculator to add all that up, why didn't you just use the calculator to start with and go, you know, use your Math 9 skills right here, right? And say, well, hey, this is equal to 30.375, and you're probably right. I should have done that, but there you go. You saw me do some algebra, and now you know how to integrate with respect to y. So that's it for this video. We'll see you in the next time.